guys, it seems like we were just together a minute ago. So we are on our science energy. It says pages 75 through 78. So go along with me and you'll see what I mean by that. A couple of those pages you're going to prepare yourself and you're going to give me your results, okay? I know I'm playing with my hair a lot, but you know, I've been cutting it myself. So those are the results. Alrighty, let's go with blue. Okay, so we're on page 75, talking about stored energy. We've talked about stored energy just a bit. Actually, the pen I'm using right now has stored energy, right? Right now, the energy is stored inside of it because it's not even moving. But once I use it, it is using the energy stored inside to do something, right? It says, you know that energy of motion can move from one thing to another. Did you know that energy can be stored? It says, read each paragraph about energy. Draw an arrow from the source of the stored energy to its change into energy of motion once it becomes in motion. Read the first box with me. Energy can be stored in a battery, right? This battery just sits there doing absolutely nothing, right? Battery, da 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 da, right? It just sits there. But when you put it inside of something like this toy and you flip the switch to on, the stored energy from the battery makes the toy, see if I can do this, makes the toy car operate, right? However that looks. Maybe it's got little pipes going out the back. Okay, so the energy that is stored in the battery can be transferred to the toy and make it go. Now, energy can, so your arrow is going that direction. Energy can be stored in a fuel. The energy stored in gasoline makes the lawnmower move. So where are we going to start? We're going to start with a can of gasoline, right? That's it, folks. Gasoline. And the gasoline is going to go to the what? Tractor. I will not even try to draw a tractor. There, you got it. So the gas sits there, not moving, not doing anything, but it has stored energy to cause the tractor to be able to move, or the lawnmower. Energy can be stored in food. Interesting. Have you thought about that? So you got a salad with tomatoes, and maybe you've got carrots and cucumbers, and you've got all this delicious looking food just sitting there until you take it into your body. And you know how you feel when you're hungry or you need some food, you want to get some energy, you need to eat a meal if you're starting to wear down. It's like putting gas in a car. We put healthy food in our body, and that causes us to be able to what? To be able to run, play, think, feel, act. And so when you eat your food, your body uses the energy to give you the strength to move. So there you are, one leg's up in the air, you are running for it, your hair is flying because you're in a big hurry, okay? There you got it. Okay, so look on page 76, it says, there are other ways to store energy. How can you store energy in each of these toys? What will each toy do when the energy is released? How can you store energy in each of these toys? What will each toy do? So that little robot, why don't you circle the little windy thing, because when you twist that, there's probably a little rubber band in there that's going to cause that little robot to work. Jack in the Box, I think we even drew one of these, didn't we? One of these dilly whoppers. Okay, you want to circle the handle because when you wind the handle, it's going to cause a jack-in-the-box. The top, circle this thing on the top that you push up and down, causing the top to spin. And the flashlight, like, who showed me their flashlight? Flashlight. I am tired. Gavin L., was that you that showed us your slingshot? Might have been. So you want to circle the rubber bands, right? Because when you pull those rubber bands, that energy stored in the rubber band, when you release it, will cause it to go forward and shoot the rock or marble or whatever. Okay? It says, look at the picture. How can energy be stored in the swing? What will happen when the energy is released? Well, energy is stored in the chains, isn't it? And when the chains are pulled back and let go, and then it will display energy of motion. Go to the next page, and this is what you're going to be doing yourself, and then next time we're together, I'm going to find out what you did. Okay, you're going to be doing an experiment. First of all, you have a question, and the question is, will the height a ball is dropped from affect how high it bounces? So let's say, and remember when you do these and make a hypothesis, it's, if you don't get it right, it's not like wrong, it's an experiment to discover what would be the answer. So let's say here's your floor, here's your floor. So you hold the ball right here and you drop it, boing, and it bounces up, okay? You hold the ball up here and you drop it, boing, and it bounces up. You hold the ball right here and same size ball, let's say, you drop it and it bounces up. Are they going to all bounce at the same height? Will the ball drop from here, bounce to there? Will the ball drop from there, bounce to the same height? And will the ball drop from way down here, bounce to the same height? That is our question. Or will each ball bounce to a different height? Okay, you're going to take a guess, an educated guess. This is called your hypothesis. So look at number 2. It says, what do you think will happen? Circle. The ball will bounce higher from the higher starting point. So you say, the higher the ball, the higher the bounce. If you think that's true, circle that. If you think the next statement is true, the ball will not bounce higher from a higher starting point. If you think it does not matter what point you start the ball, that it will bounce the same height, that doesn't matter. Circle that. Now, the deal is you are going to research this yourself. You can have a little ball, you can have a tennis ball, you can have a basketball, you can have like your dad, or you can stand on a chair, bounce it from up high, have somebody maybe holding a yardstick, or kind of show you with their hand how high it bounced, and then hold it down low, have that person mark with their hand, or however you decide to do it, how high that bounce is. And then you're going to record your information on the chart on page 78. It says, if the height of the drop is 1 foot, what's the height of the bounce? The height is 2 feet, what's the height of the bounce? And 3 feet. So you're going to make a conclusion. You're going to say the energy stored in an object, say the energy stored in this ball, it's the same ball. You're going to use the same ball, okay? Use the same ball. Have I said that yet? So, use the same ball, so you make sure that's the same. You just drop it from different heights. So, you will conclude that the energy stored in an object decreases or gets less as the object's height increases. Or the energy stored in an object increases, bounces higher as the object's height increases. Decrease means to go down. Increase means to get higher. okay? So when you bounce that ball from here and it bounces way up to there, you can say that the height of the ball at 1 foot, the bounce increased. Let's say this is 3 feet and you drop the ball and it only bounced there. You would say the higher you bounce the ball, the lower the object's height decreases, okay? Or it could be the other way around. Maybe letting go of the ball from this height will cause the bounce to be higher. Maybe from this height will cause the bounce to be lower. You find out, okay? And then we will do number 6 actually, and we will share what we've learned next week. All right, so you've checked that out and get some help maybe from an older sibling or a parent, and we will see you next Monday, okay? Have a good weekend. Bye-bye.